So this is my great big mess. I got 60 coal cars, and they're in the process of, they're on the track, they're finished. So there's two major different types. That's the prefix numbers for the numbers that are on the sides of the cars. 527 column, 528 and 529. 529s are already, they come with a number on the side already. Now, that's actually not one of them. I'm trying to think of, I have it right here. These two numbers. That's the only two that came with numbers already painted on. Everything else is done using these decals. So there's your 527, 528. And then you have all these numbers. And out of all those numbers, I still just cut them out 3 and 3. So these numbers that are covered with parts. The first, let's see, here's a decal that might help it make sense if I can get a hold of it. So the one I just showed, I would cut out the 527, and then where you see the 937, I would get it from those first three numbers over here. 937. And that's how I came up with all 60 numbers. Now, like I said, there's two that I just went ahead and, could use. Those are the two painted numbers. The rest, I had to do those decals. So, yeah, they don't stop there. There's another 6 over here. I had 2 over on the floor that have sticky notes on them because they're missing parts. So it's kind of hard to tell because this is, all the rest are considered, anything that's 527, 528 is unnumbered. And I don't have an example anymore because I did all the decals. And they turned out pretty good. There, that's a pretty good angle right there. You should be able to see that it is a decal. And I had set up a little caliper that would measure below the lip down to where I want it. And then there's this stuff called Solviset, because I tried it with water. I've never had a problem putting decals on with just water. You just put them in the water bowl, get it wet, and within so many seconds it just slides off. You put it on your model. But either the glue or the fact that this is a flat color paint or both, it does not work. But this stuff is very strong. In fact, I had to kind of experiment to make sure it wasn't too strong. or I'd have to dilute it. Anyway, that's just one of the numbers, just a random. Oh, there's one on each side, same place. But if that's not enough, you get to do that on the end as well. Both ends. So each car has, let's see, 1, 2, 3, 4, 5, 6, 7, 8 decals per car. So there's all that. And then these that I'm doing now, see, these are all the parts, and it may look like it's a lot, but it really isn't. There's not many parts to this. There's these little bottom pieces, look like that. I mean, you can see these are all the same. These are all the same. These are the little brake wheels, the little cylinder, and stuff they use for the brake system. These go on each end. They have the little step in each corner. There's two types. There's that type, and then it may look the same, but it's not. This one has a couple extra little holes. So this end is the one that gets one of these and one of these. Oh wait. Oh, I'm sorry. One of these. So that's like a air reservoir. So the way train brakes work is the engine itself generates air pressure. And as it does that, each car is coupled to each other, and it pressurizes each car separately down the line until they all reach a certain pressure. And it's a fail-safe system. So if one of the cars, the coupling comes undone, or for some reason the train itself uncouples, the cars from that point on don't receive air pressure. And the air pressure is what keeps the brake shoes off the wheels. So that's why it's fail-safe. So in its natural state, the brakes are on. I believe that's the way trucks work as well. It's the opposite of cars. Which, see, I mean, it's a good idea. That way, like I said, in the past, they used to have some poor guy that used to have to run over the top of box cars. That's why the wheels, these little wheels, they turn that to apply the brakes manually. He'd have to run along that train while it's moving and turn the wheels one by one to help slow the train. That is extremely dangerous. So anyway, that's how this system works. And those four B&Os, B&O, C&O, and Chessie, which I don't have a Chessie right now. It's one of my favorite locomotives. And then, oh, it's behind there, a C&O. You can set up two different sets of brakes. There's the independent, which are brakes just for the locomotive, and then the train brake. And the train brake is what controls the braking of all the cars, because the locomotive itself cannot stop a train. It would just, the wheels would just lock up and slide. So it all acts as a unit when they're all coupled together. Those locomotives have sound in them. I'll fire them up in a minute. This is actually going to get sound. So this one is a little special. There'll be 9 of these. The trucks, that's what they call the bottoms that have the wheels on them. They call them trucks. These are electrical pickup trucks. And I've modified the model by drilling these holes up through. And it picks up, there's 2 wires coming up through each hole. And that picks up electricity from the rail. And then the next step would be, I've got one that's finished. Those 3 components. One is a 1-inch speaker. The white is what's called a decoder. And it picks up information off the rails. And let's see, there's a better way to describe this. In the past, model railroading just used DC power, direct current. And the more you turn the little throttle up, the more power you're sending to the track. And that's what would make the locomotive go faster, because it's just a motor inside, a DC motor. So if you give it more power, it goes faster, and if you dial it down, it goes slower. And that's what my first train set I got back in, I think it was 1977. And that's how it worked. Now everything is, well, first of all, let me just say, if you want to run more than one locomotive and they're not coupled together like these down here, then you're going to have an issue, because when you turn your power supply up, all the trains, all the locomotives on the track are all going to move. And if they're separate locomotives or trains, a train's definition is the engine with cars. So I typically, over the years, have gotten over the habit of calling these 4 units right there a train, because they're really just, they're engines. So suppose you have 2 or 3 different trains on the layout and you want to control them individually. There's little tricks they came up with, but nothing like what I see now. And they've been tinkering with this since, I want to say, the late 80s. And it's called DCC. It's Digital Command Control. And so the system I'm using is called Digitrax. And what it allows you to do is each locomotive gets a decoder. That's why when I said decoder, I thought, well, I better back up. All these buttons, it looks pretty complex. And I mean, when you first jump into it, there is a learning curve, but it's well worth it. So instead of the tracks receiving more power to go faster and less power to go slower, DCC energizes the tracks equally. And I want to say it's somewhere around 15 or 16 volts. But what has changed is between the little motor that's inside each locomotive is a decoder. So you've got the tracks that have the power. It not only has power, but it can send a digital signal down the rail sent by the throttle here, is what they normally call it. And you can pull up locomotives, or in this case, even this is called a sound car, and it mimics the sounds that a car makes. Rail car. The sounds from the locomotive are going to be what I've installed in those. They didn't come with that decoder in it. That's a whole nother subject, I guess. A lot of the manufacturers tend to put their type of decoder in it already, and it's become almost like a monopoly. And I personally don't care for it. The name of the company that I buy all my stuff through is called Soundtrax. Okay, they've been doing this since 1990, and this is some of their newest stuff. So this is, the decoder in here is called a sound car, and the decoders that are in the locomotives, you have to choose. There's several different type. Those are made by EMD, which is actually a division of General Motors. And they have another type that's similar. And trying to think of an example, but it's basically, they're made by GE, General Electric. And I found that kind of interesting as I grew older and learned more about this stuff. I don't know what year those came out, but I do know it was within the 60s or early 70s. They go by different designations. Those are designated as GP 38s. The GP stands for basically general purpose. And in the past, they would just take as many, they do the load calculations and where they're going to go and how much they're going to pull, and that would decide how many locomotives they need to pull together. Because each one of these, I can't remember if it's 1,500 or 2,000 horsepower. They do have, I believe they have a very early type of turbo in them. And that's, between that, the engine's getting larger. Most of the ones you see going by now, the engines are longer. And they usually have about 4,400 horsepower. Anything much larger than that, and they've proven to kind of destroy themselves. It's just too much power. They tried doing a 6,000 horsepower engine, and it didn't last, it didn't work. It tore itself up. So anyway, these are older. I do have a couple newer ones upstairs, but this is all about like B&O, C&O, and chassis to me. And I like trains that are long, so this, I think I mentioned, will be 60 cars. I plan on having like little pieces that sit in the top that look like they're hauling coal. So on these models, they don't get the little, there's a little plastic piece in each end. That's the side you'd see. And the reason why is nobody's going to see in here because it will have a cover on it. I will not even attempt to gracefully put this on here. But I had made, this is just a sheet of plastic. They call it styrene. I had to kind of taper the ends because the top of the car is tapered. And this thing will sit right in there just below the edge and cover all of this up. And that's what I plan on doing to all the cars. But I made that one just so when I look at this, it's not so ugly. So it picks up the left and right rail here, the left and right rail here, and then ties into the decoder. And then the decoder allows you to dial up either a car or a locomotive by an address. And it makes the most sense to program or set the address to the locomotive number. So this one is a 3840. So if I were to pull that one aside separately and want to run that, I would come into here and press loco 3840, enter. Now right now they're in a advanced consist, and its number is 38. Now I'm going to go ahead and turn on the track power. So just press power and plus. There we go. And when that little red light's on the panel there, then I know I'm good. All right, for the locomotive, I'm going to put in 38 and enter. I'll change direction to forward, and I will turn on the front light. It gets a little tricky. This is what you call ground lights, step lights and walkway lights, number boards, and the front class lights. So I'm going to dim the lights here a little bit. And hope it picks it up pretty well. I always, when I'm doing these, I always redo them because the headlight is never bright enough. So there's the headlights. These are called number board lights. They turn on separate. This is class lights. They don't use those anymore. It was a way to communicate to other locomotives as they pass each other. And then below here is a walkway light. The one that's on the ground is called a ground light. And the one that's over here where they step up is your step lights. I did those. I actually have to redo everything when I get one of these because it just doesn't have what I want with it. So since it's on an advanced consist, the lead engine, I can turn all these lights on and off. The other three, the only lights I care about are the number boards. So all three of these light up. You can hear just some random sounds. Now, whoops, turn the lights back up because you won't be able to see that, but I want you to be able to hear it. All right, so if I go back to just, there's two things I can do. I can either give it just one slight turn, because this one will control one locomotive and this one can do a separate. But since all four of those locomotives are what they called consisted, that just means they all run on that same address of 38. And then if I want to change that, I can go into the programming, and with one simple change, they will all go back to being separate numbers, like 3840, 3824, 3817, and 3801. But right now they're all together on 38. So the lights are on. Here's the bell. There's a lot of different type of bells. There's over 40 different horns, but I've landed on this one so far. Okay, and then if I give it a little bit of throttle, that bell is a low oil pressure alarm. I found it very interesting that to start one of these, there's a bunch of switches inside you have to set up correctly. And then they come down about halfway on the opposite side and open the door. These things have doors all the way down each side that are kind of like locker doors that you would see in a high school. And there's a little latch at the top and bottom, and that's how you can open and service the engine. So on the opposite side, there is a door at the back of the cab. There's one on this side in the front, but on this side, the door for the back is on the opposite side. And he comes down and primes the engine. And then after so many seconds of priming, he flips the switch over to start and presses and holds a button. And that's what starts up the locomotive. And then there's a handle there as well that he can use to like rev the engine. So just very briefly, and I didn't know this, locomotives of these type, they're also called diesels, because there's a big old engine right in the center that is a diesel engine. And I used to think that's all there was to it, and that's not true. Each engine is like its own power station. And so the diesel engines, they don't have like an accelerator like a car. They go from notch 0 up to 8, depending on how much power is needed. And 8 would be the highest. And I can simulate this by pressing 5 or 6. So I'm going to go ahead and take it up to notch 2. And there's notch 3. Notch 4, notch 5, 6, 7, and 8. Now I'm going to slow them down. Okay. And I hit it one extra time, which makes the engines go into shut off. So, how are the diesel engines connected to the wheels? Well, they're not directly. The diesel engines turn a generator, and it produces electricity. So all the wheels have a electric motor between them, and that's what drives the train, the electric motors. So if you need more power going up a hill or whatever, there's a lever where you notch it up higher and higher to speed up. And all that does is just speed up the diesel motor and provide more power to the electric motors between the wheels that are on the track. That's how the real locomotives work. I found that pretty interesting. And as time went on, they were able to find different ways to get more power out of these. Like I said, I can't remember if these are turbo or not. If it is, it's a very early version turbo, because typically the turbos have a bit more of a whine to the sound, and they're quite realistic. I'll fire it up one more time and then show how the brakes work. And it will not move until the engines are all turned on and ready to go. So I'm going to inch it forward. At each end I've got one of these, actually I forgot what they call them, but it'll not, one of these. It won't allow it to go off the end of the track. Okay, I'm going to stop it right there. And I'm going to reverse it. And when I do, only the last engine headlight comes on. It has what's called back EMF. So if you start going uphill or pulling a load, it will simulate that and it'll automatically notch up. I'm going to demonstrate that just by putting my finger on the track, and you'll hear when the engine speeds up automatically. See, it's doing that automatically. I'm not doing it. As soon as the load is off, they go back to, because I've only got it within like notch 1. Now the only other thing that's interesting here is I can apply the brakes by hitting F11 and you'll hear them. And then F11 again releases them. And then I'll go ahead and shut that down. So the sounds and everything it does is very realistic. It's nothing like it was back in the day as far as the hobby of model railroading. So every time I send commands from here, the locomotives say, okay, I'm being talked to and this is what I need to do because of the address. Now right now I'm just kind of clearing the address. And let me pull up, tell you this, the work table is getting pretty tight. So this is how a sound car works. You put it on the track. I have to move this for a second. It's just totally been in the way. I'm going to put in a new number. And it's not a locomotive I have. It's just 1, 2, 3, 4. Enter. Okay. So on here it says 1, 2, 3, 4. So we're going to just imagine there's an engine on the track and it's numbered 1, 2, 3, 4. I have to find my little magnet tool. Alright, so I found it. It's just a little, here's a magnet on the end here, and then you can pull this out to be like a pointer. On the side of the car, at the back here, there's that little brake wheel, this here. So what you do for one of these is just put the magnet there we go. And when you hear that sound, you press F8 4 times. And that's the sound of the air bleed off. Now it's letting you know it's consisted, just like the engines, but it's done a little bit differently. So when I turn up the throttle now, you're hearing the clickety clack and the flange squeal. And just basically the sound that a car would make as it's going down the rails. And the faster I turn the throttle, the faster the clickety clack and all this. And it's really cool. I like the fact that they've taken the sound and not only put it in the engine, but you can put it in these cars as well. Now I'm going to press again, F11 is the brakes. You can hear that squeal. That's the brake shoes against the wheels. Okay, and there's a number programmed into the locomotives under brake rate, and that number is the same number that's programmed into this car decoder. And since those two numbers are the same, when the train comes to a stop, the cars stop squealing as well. And I've got a CSX video I can pass on if I didn't already. So that's basically it. I mean, they've really come a long way. Now that little decoder that's in the locomotive, or not locomotive, the car, it can do all kinds of things. It can operate several different lights. It's got horns, whistles, and you'd probably be thinking, why would you need like a bell or horns and whistles? Because on that yellow caboose down there, I've got a little red light on each end that flashes just like the real one. And it also has, they use the air that comes through the whole train line, like I was talking about. And the air that comes through there is connected to a whistle, on the caboose. So if the caboose is, or the train is backing up and they're coming to a crossing to warn traffic, they still have to blow they have a pattern. It's 2 long, 1 short, and 1 long blast of either the horn or the whistle. So the caboose would still need to do that, and that's how it does it. So I've got, I think it's 7 different Chessie themed cabooses, and like I said, the little LED on the end, I can turn on either end that I want, and it flashes red real slow, just like the real one would. There's also, you can program it for livestock. So if this was a stock car and you wanted to hear cows, you will hear cows, or sheep. There's a mechanical refrigerator, and it's kind of like a refrigerator in your kitchen, but it's cooling down the entire car. And they run independently of the locomotive in real life. They have a AC unit type thing on the end of the car. Semis have got them too, but unless you know what you're looking at, you probably wouldn't even think twice. But that's how, things that are either cooled or frozen can get across the country, and that's built into that decoder as well. I have it programmed to do just what it does, and that's the clickety-clack. And every 6th car will have that sound in it. And it really does bring a whole different level of realism to the layout. So basically everything that's sitting over here is, you got the decals, and it's just waiting to be assembled. There's nothing assembled on any of these yet. And then I went through them all to make sure there weren't parts missing. I had a few of the short screws missing, and then the entire sprue, is what they call it, on a plastic model, has both these ends, this piece and this piece here, the reservoir, missing. So they're going to be sending me that. There'll be a total of 9 sound cars, and to put that in perspective, this whole train will be over 30 feet long at a layout. And that's not including the locomotives or the caboose. I just like realism, so that's why it's so big. 60 cars is actually not too bad in real life when you're sitting there, and if you start counting cars as the train goes by, they're, many times they're over that easily. So my other, I call it train because it is a train, is CSX. There's a very early model CSX. And those are new type units, type that you'd see on the railroads today. And I have 40 of those coal cars. And again, I'll send a link so you can see it. They've moved from steel to be able to make these, they're called hopper cars. They've moved from steel and are able to make them mostly out of aluminum, which saves a lot of weight. And so my CSX ones are all kind of shiny. They have a aluminum look to them. And I can't remember how long that train is, but I ran it only once so far, and it is really long. I'll have to get out one car and measure it, and then times it by 40 to see how long it is. And I wanted this one to surpass it because I'm more into when I was young, watching these in the late 70s, early 80s. So anyway, that's pretty much it. It can get a lot deeper, but the evolution of how this hobby has changed is just insane. So the last step on the sound car is, suppose you've pushed the car back to let's say it's just a company and you're going to drop off the car. So it's not going to be connected to the train anymore. So what you do is run the magnet across again. So that sound you just heard would be somebody turning this brake wheel and manually setting the brake. And that little kind of squeak at the end is a trick where they will put a cheater bar through the openings on there to get a little more leverage to get it tightened down. And now that car is disconnected from the system. Oh, the purple, I didn't show that. But if I had that thing going and you hear the clickety clack and flange squeal, I could lift it off the track and it would literally go for probably another 20 seconds. The purple, it's called a current keeper, and what it does is it backs up power. So when your locomotives or cars, because the locomotives have them in there as well, go across, say, a dirty part of the track or a switch where it may not be getting the best connection to the rails, it will fill that in. I can't stand trying to run these things and have them cutting out, the sound going out and coming back on, and they're doing all kinds of weird things. But you put the current key, yeah, it just kicked off just now. I just heard it pop. So it just, it plugs in on the end there of the white. You probably can't see it, but it comes with a little pigtail on there, and you just plug it right in. The first time you put it on the track, well, any time you put it on the track, it charges, but really fast. And so the white part's the decoder, and somewhere in the middle is where there's a little reed switch inside it, and that's what the magnet trips when you run that along. Now normally it would be on top like a box car. You'd want to mount that thing onto the roof inside, but since these are coal cars and they're going to have, you know, I didn't want to mess with that at all. It's going to have one of these plastic strips, then some foam, which I'll custom kind of carve, and then sprinkle some tiny pieces of coal on it. And you're supposed to hit it with a little bit of gloss clear coat, and that way the coal is kind of shiny, and if you don't do that, it ends up looking really dull. So the foam will sit on here, and that's, like I said, what I have to use, like one of these little knives to carve that. And then you can just take regular Elmer's glue and paint it on, just using a paintbrush, and sprinkle the coal on it. And then when you're done, you shake it off, see if there's, you know, any loose, and then you spray it with a little bit of water and glue. It's like a mixture, and just a drop or two of Dawn. It makes it disperse out better. You can sprinkle just a little bit more on there if you want, and then you just collect what doesn't stick and move on to the next car. So every one of these will have one of those loads in it, so it looks like it's pulling coal. But what I'm saying is it's so thick, the material, that I didn't want to mess with trying to put the decoder on top like you normally would. If this was a box car, I'd put it under the roof and just run this along the top. But in this case, I know which side the brake wheel's on and come around to that side, because it does favor one side. Anyway, I didn't think that this video would get quite that long, but that is what I am in the middle of. So this is all the parts it takes to make a car. I think I mentioned all these are stacking up over here because I don't use them. This is what would be considered the truck that's underneath. And then next to it, they all get these metal these metal wheels, because they come with plastic wheels, and plastic wheels are just pretty much garbage. But when these come in a pack, I put it down on the floor, that truck is already assembled and ready to go. I'm gonna grab one. It's a little hard to see, but all this is HO scale, and it's from a company called Tangent. This is equipped with power pickups, so it's a little hard to see, but there is a wire, 2 wires wrapped around each truck, and I just unravel that from each one, and it's got this little, they must be using this little plug-in for their stuff. I always just cut it off, and then I have to drill up through the plastic from underneath. Well, there's a little light, yeah, in the center. You see the wires going through that hole. And when I first come up, I just kind of hold with my finger the weight. So there's the weight. And I start with a pretty small drill. And when I drill up, it's going to leave a little mark on here. And so I do it for each end, and then I use what's called this is a paint pen. It's not a typical marker. It actually dispenses paint. And I usually just draw something that looks like a 1 on one of these, and then they get 2, 1 on each end. And the other one, I just touch it so it's just like a dot. And I do the same thing inside the car before these go on, like this. And the weight just goes down in like so. But the important part is, that's where I go out to the garage with those 3 different size drills, and I use a punch to better locate the center of where the drill hit it, because they're all going to be a little bit off, like custom. So I'll punch it and then go back and drill it with the 3 different sizes. Then I just very, very lightly hit it with another drill. It's kind of hard to see, but that way I don't have a sharp edge. You can kind of see that shininess around it. That's where a larger bit I did that so it would have what's called a chamfer, and that'll keep the wires from getting cut over time, because as this thing's going around curves and everything, the trucks, they steer along the curves, and the hole is big enough so it's not going to restrict anything. So that's what I have to do to get it ready custom. I do have one other that's on the track, and it's hard to see, but there's a little rib on each side. On one end, I have to cut it off completely, both sides. On the other end, I just take some off. And the reason for that is, if I don't, that rib will be in the way of the current keeper and the decoder. And down here, I don't have to take it all off, but this is a speaker enclosure. Some of it needs to go past those ribs, so that's why I cut it. And then on the bottom, I carefully drill those 4 holes. They should be kind of in the center. 2 there, and then 2 there. And you heard it. The sound comes through with no problem. So anyway, that's just diving into, I guess, a lot of things. Going from DC to DCC, where everything is digital now. I'm going to go ahead and shut the, let's see, double check to make sure everything's off. 1, 2, 3. Okay, and then power off, the light goes off. Now, you might still hear some sounds coming from these engines. I can hear just like a very, very quiet hiss, and that's because they have that current keeper in them. And it won't last near as long if they were running, because between the sound and having to turn a motor, it eats up the power a lot faster. But they won't cut out. If you don't use that, then yes, they would. And do I have? It's buried. Oh no, it isn't. Well, it is buried, but this is what I went digging through this the other day to find something. This is what a traditional power pack would look like. And again, that's all you do is turn this. The more you turn it, the more voltage goes to the track. It's pretty straightforward. This one, you can turn the power pack on and off. And then this one changes direction. I only use it to do test lighting. And there's a red wire and a black wire coming out the back. And I put a little red on this side so I'd know that the switch needs to be that way, so the red wire is positive. So this is, I mean, I had my old one forever and it died. I ended up having to get a new one. But that's all it's really used for now. It's just testing lighting or electric motors. But that's how they used to run. You just connect that to some track, and the model has a little motor in it, and the more power it gets, the faster it goes. But now the DCC, that's basically changed everything. You got to make sure that decoder is wired in a way that it receives the track power, and the motor inside the locomotive has to be totally isolated. It can't have any electrical connection, and these newer engines are built that way. So instead of looking for track power, they connect to the decoder, and it's got 2 wires coming out of it that connect directly to the motor. And that's how that works. And then there's a bunch of other functions. There's up to 8 different functions you can control based on how you wire it. And I've used all 8 on all these, because each one of these engines, just one, has 19 LEDs in it. So a lot of work went into these, a lot of custom type of work. I'm not using the same kind of speaker. It's not round like this. They call them cubes, and they look rectangular. And toward the back, if I were to remove the shell, you'd see 3 cubes for each engine. So that's 3 speakers per engine. So sitting right there, you got 12 speakers in all 4 of those engines. Anyway, that's basically what I'm doing now, and it'll take a while to finish this. I'll probably only prep the sound ones for the one I've got, the one I finished, this one, and then I have this one and another one on the rail. And I think I'm only going to do one more because I only have enough decoders coming for 3, and I don't want to get ahead of myself. If for any reason I don't go ahead with the rest of these cars under the paper being sound cars, I don't want to go in there and start breaking pieces off and drilling custom stuff if I'm not going to put sound in them. So anyway, this is my little factory, and when it's done, I'll have to get a video when it's at the layout, kind of like the CSX one. But right now it's just, I'm looking to get this done so I can clean up a lot of this.